Hi folks, today we're going to talk about questions involving systems of equations at the intermediate level. So let's get started. Let's find the solution to the following system of equations. 3y minus 7x equals negative 2 and 28x minus 12y equals 8. The difference in this system of equations and other previous ones that you might have encountered is that we don't have a variable that's readily available to solve for. So in order to start this problem, we're going to actually use the elimination method, or also known as the addition method. So in terms of what we need to do first, our first step is to actually line up our variables. So we want to get the x terms aligned with each other, the y terms aligned with each other, and the constants aligned with each other. So what does that look like? Well, then you get negative 7x plus 3y equals negative 2, and then 28x minus 12y equals 8. Notice how the x terms are lined up, the y terms are lined up, and we have our constants lined up. So moving forward from here, where do we go? Well, we're going to take multiples of equations to try and have things cancel out. So if you notice, if we multiply that top equation by 4, all of a sudden we would get that negative 28x, and that would cancel off with the 28x. So we get negative 28x plus 12y equals negative 8 when we multiply that top equation by 4, and then 28x minus 12y equals 8. So with our third step, all we need to do is actually add these two equations. So if we go negative 28x plus 28x, you get 0x. If you add the 12y and negative 12y, notice you get 0y, and then finally negative 8 plus 8 equals 0. So we end up having the 0 equals 0 on both sides. Moving forward from there, well, that actually gives us some information. Notice that will always be equal, 0 always equals 0. So we actually have infinitely many solutions to this system of equations. And so this is a common way to see it. You'll have two numbers that end up being equal to each other and no other variables involved. So this actually gives us the solution is just pick either one of the lines. So if we pick negative 7x plus 3y equals negative 2, so just coming from equation 1 right here, that's actually satisfying our condition. Any of those lines are the same, basically. You have these lines lying right on top of each other. Okay, so on to the next question. Let's find the solution to the following system of equations. You have 4x equals 6 plus 5y, and then 1 equals 3x minus 2y. In order to go forward on this one, a slightly different manner, we need to get everything on the same side, and so you might have to move some equations over, but if you move the 5y on over in that first equation, you get 4x minus 5y equals 6. And on the second equation, we can just flip-flop the sides, so you get 3x minus 2y equals 1. Now, where do we go from here? We want to try and ideally cancel out equations, but notice there are no common multiples, so you can pick which one you want. If you want to cancel out the x's, you can pick the necessary multiples by equation 1 and equation 2 to do that. I would say the easier one here looks to be the y terms. So if you notice, if you multiply the first equation, let's say by 2, and notice you get 8x minus 10y, in our second equation, what would we need to multiply that by in order to have the y's cancel out? Well, we need, if we have negative 10y here, we need positive 10y. So we need to multiply the second equation by negative 5. And if we do that, we get negative 15x plus 10y equals negative 5. Now we're ready to add up these equations. So adding up these equations, 8x plus negative 15x is going to give us negative 7x. Since we've done things properly, when we add negative 10y and 10y, notice that we have just 0y, which turns to 0, and then 12 plus negative 5 makes 7. So we have negative 7x equals 7, and you can simply just divide both sides by negative 7 to get x equals negative 1. So moving forward from here, all we need to do is plug in x equals negative 1 into one of the two equations. And if you look, it doesn't matter which one you choose, but the 3x minus 2y might be a little bit easier to solve. So let's plug into that one. So with that in mind, we have 3x minus 2y equals 1. And you plug in negative 1 in for x, and notice this gives us 3 times negative 1 minus 2y equals 1. So that's negative 3. When you add 3 over to the other side, you get negative 2y equals 4. And our answer, y equals negative 2. So this actually gives us a solution to the system, and that solution is negative 1 for our x value and negative 2, so the ordered pair negative 1, negative 2. Okay, So on to question 3, we're finally getting to some word problems. So let's say Gregory Mendel wants to use 20 feet of fencing to enclose a rectangular piece of land with an area of 24 square feet. Is it possible for Gregory to make such an enclosure while using all 20 feet of fencing? So we want to basically provide some evidence in either form. Now, when we take a look, you have a rectangular garden that we're enclosing, so we're just putting labels on this. So we'll say our length is x and our width is y, and we can actually label those in feet. Or actually, I believe I called it here, the length in feet. Oh yeah, shall be given by x. It really doesn't matter what your labels are, you get to choose from there. But according to our rectangle, length will be x, our width will be y. Now, what does our equation look like? Well, we know that we have 20 feet of fencing to enclose the rectangular piece of land. So that means if you're walking that around the outside, walking the perimeter, that's essentially what we've done. We have the perimeter here. So our perimeter actually equals 2x plus 2y. But an easier way to do that here will be 20 equals 2x plus 2y. Now, in a similar manner, the area actually equals your length times your width, so your x times your y in this case. And so our area is 24 square feet, so we have 24 equals x times y. And there's our system of equations. So now, where do we go from here? Well, let's try and solve this system, and we've solved this problem. So see if it has a solution. So we're going to let x and y denote the length and width in feet respectively. And we're solving this system where your top equation is the perimeter, your second equation is the area. So our first step to solving this thing is actually just solve for a variable. And if you look at the second equation, you can solve for y quite easily. Y equals 24 over x. And now we want to substitute that in, since we have a nice thing to substitute in for. So if we substitute that into the top equation, we want to replace the y value. So we get 20 equals 2x plus 2 times the quantity 24 over x. Now, you might get scared because we have a fraction. Don't worry. The only caveat, when we divide it in that first step, we can't be dividing if x equals 0. But that doesn't make any sense. We don't want a fence that has no width. So we can actually multiply both sides by x. And if you multiply both sides by x, what pops out? Well, you get 20x equals 2x squared because we multiplied both of those terms times x. And when you multiply the last term by x, the x cancels out with the x in the denominator, and you're left with 2 times 24. Well, this is just a quadratic, a nice simple quadratic. And so that quadratic is 0 equals 2x squared minus 20x plus 48. But if you notice, you might say quadratic formula at this point, but actually it's not necessary. If you look, you can factor out a 2 from both terms. And so you get 0 equals 2 times that quantity x squared minus 10x plus 24. If you divide both sides by 2, now you have a nice quadratic equation that we can work with. And so from here, all we need to do is just factor. Actually, this one factors nicely. It's x minus 6 and x minus 4. So we get 0 equals x, the quantity x minus 6 and the quantity x minus 4. Now, how do we solve this? Well, you set each factor equal to 0. So we have x minus 6 equals 0 and x minus 4 equals 0. And then you just move those terms over to the other side, and we have our answers of x equals 6 and x equals 4, or put it in set notation, x equals a set of elements 6 and 4. Now, usually we try and solve back in for y, but actually this is kind of telling us some neat information. In terms of when we plug that back into our equation, we have y equals 24 over x. So when x equals 6, y equals 24 over essentially 6, which is the same thing as 4. So you have 6 and 4 kind of matched up there as an ordered pair. And vice versa, when x equals 4, you plug it into that y equals 24 over x. You get 24 over 4, which equals 6. So notice, if you have x equaling 4, then your y value equals 6. If your x equals 6, your y value equals 4. Well, that's telling us something about the relationship of the length and the width here. Essentially, what happened is it didn't matter what we labeled our length and what we labeled our width, because either way, your dimensions are going to be 6 feet by 4 feet or 4 feet by 6 feet. So actually, we can do this, and the appropriate measurements are 6 feet by 4 feet, or as I said, vice versa, you can do 4 feet by 6 feet.